Hey guys, and welcome to lesson 5.9, logarithmic equations. So in today's lesson, I'm going to show you a couple examples where we have logarithms, and it's very similar to the solving exponential equations lesson. So if you take a look at what's highlighted in yellow here, it says if log base b of x equals log base b of y, then it must be true that the arguments x and y are equal. So it's very similar to the exponential lesson where you have the same bases. So in both cases, the bases are the same, then the arguments are equal. There are some instances though when you have a logarithm that equals some constant number, a. So if log base b of x equals some number, then what you're going to have to do here is change to exponential form and then solve from there. Okay, so two situations. When you have all terms being in terms of log, then what you want to do is simplify so that there's one log on the left side and one log on the right side, and then we can say that the arguments are equal. And the other situation is when you have some logarithm equaling some constant number, then you change to exponential form. So we will go through that, but one thing I do want to point out is that we do have to check our solutions. You have to make sure that your argument is greater than 0, your base is greater than 0, but not equal to 1. Okay, so let's move on, and we'll start with example 1. Okay, so it says identify and reject any extraneous roots. So again, we're going to double check our final answer and then make sure that they are acceptable answers. So in example A here, we have 5 log base 3 of 2 equaling log base 3 of 4x. So you'll notice that we have every single term is a logarithm, and they both happen to be the same base, 3. So what I'm going to do is let the arguments equal each other. But before we do that, you'll notice that we have coefficient 5 here. So I'm going to use the power rule and change this so this is log base 3 of 2 to the power of 5. Okay, so when you're letting arguments equal each other, make sure that there's no coefficients in front. So now I'm going to say, well, they're both log base 3, so that must mean that 2 to the power of 5 is equal to 4x. And from here, we can solve for x because we know that 2 to the power of 5 is really 32. And now we can just divide both sides by 4 and say that x is equal to 8. Okay, so let's go back up and check our solution. So the only place we can sub in x equals 8 is right here on the right side here. Now if I subbed in 8, we'd have 4 times 5, or 4 times 8 equaling 32. That argument ends up being greater than 0, so we're good. So we'll move on to the next one. So again, I take a look. Every single term is written as a logarithm, and every single term has the same base. Okay, so what I want to do is, the first thing is get rid of any coefficients and change them into exponents. So on the left side here, I'm going to change this to log base 10 of x squared. And on the right side, I'm going to use the product law to write it as a single logarithm. So on the right side, because we have two logs with the same base, I can multiply the arguments. So I can say that this is log base 10 of 4 times x minus 1. Okay, so now that we have two single logarithms on both sides of the equal sign, we have no coefficients, we've changed them all to exponents, we can say, well, therefore, x squared is equal to 4 times x minus 1. And then from here, we can distribute the 4. And because we have a quadratic here, I'm going to move everything to one side so that this becomes x squared minus 4x plus 4 equals 0. And at this point, we can factor. So two numbers that multiply to 4 and add to negative 4, well, that would be x minus 2 times x minus 2. So I'll just write x minus 2 squared. And if we were to solve for x, I want to know where x minus 2 equals 0. Well then, that must tell me that x equals positive 2. Okay, again, let's go back up and check that if we subbed in x equals positive 2, will we still get an acceptable answer? So if I subbed in 2 here, that's fine, our argument's still greater than 0. And if I subbed in 2 here, also fine, because 2 minus 1 is still 1, and that's okay. Okay, In example C here, I don't see all terms written as logarithms. So what I'm going to do is keep all of the logs on one side, and I'm going to move all of the constant numbers to the other side. So what happens is this becomes log base 4 of 7x plus 15 is going to equal 8 minus 5, which gives us 3. So now that we have one logarithm on the left side and one single number on the right side, now we can change this to exponential form. So I can say our base 4 is raised to the power of 3, and that equals our argument of 7x plus 15. And again, from here we can solve for x. So we can evaluate 4 to the power of 3 is 64 equals 7x plus 15. We are going to move the 15 to the other side, so that'll give us 49 equals 7x, and divide both sides by 7, and we finish off saying that x equals 7. And again, if we sub in 7 into our original equation, our argument is still greater than 0, so we are good. Not all terms are logarithms, so again, what we're going to do is move all of the logs to the left side, and we'll keep the numbers on the right side. So this will become log base 2 of x plus log base 2 of x minus 2 equaling 3. Now before we go ahead and write an exponential form, we need to combine as one single logarithm. And because we are adding two logarithms with the same base, we can change it to say that this is log base 2, and then multiply our arguments x times x minus 2. Okay, so again, logs on one side, numbers on the other mean that we have to write in exponential form. So 2 cubed equals our argument of x times x minus 2. And again, we'll evaluate and solve for x. So 2 to the power of 3 is 8. And on the right side, we can distribute, saying x squared minus 2x. And because we have a quadratic, we'll move everything so that our x squared term is positive. So I'll move everything to the right. X squared minus 2x minus 8. Here we can factor. So two numbers that multiply to 8 and multiply to negative 8 and add to negative 2 must be x minus 4 times x plus 2. And then again from here, we can say that either x equals positive 4 or x equals negative 2. And again, we check. Let's check x equals 4. Well, in either case, if I sub in 4 here or here, both of our arguments will be greater than 0. However, if we subbed in x equals negative 2, we'll have an argument of negative 2 and an argument of negative 4. That would be an extraneous variable because our arguments have to be greater than 0. So the only valid answer here would be x equals 4. So make sure that this is something that you show on a test so that you get full mark. Okay, and then one more example. This time we have logs on one side, numbers on the other, so that's one step down for us. But this time we notice to create a single logarithm on the left side, we're going to have to divide because of this minus sign. So we will say that this is log base 5, and then we'll divide our arguments x plus 1 over x minus 1. And same as last time, we'll write an exponential form. So 5 to the power of 1 equals x plus 1 over x minus 1. You don't want to deal with fractions, so the best way to deal with that is multiply both sides by your denominator, x minus 1. So our denominators will cross out on the right side, leaving us with just x plus 1. And on the left side, well, 5 to the power of 1 is just 5, so we can start distributing right away. So 5x minus 5. And we don't have a quadratic here. We have a nice linear equation, so I'll move all my x's to one side. So 5x minus x. And all the numbers on the right side, so 1 plus 5. So we actually end up with 4x equaling 6. And divide both sides by 4, which will give us x equaling 3 over 2. And again, we double check. If I subbed in 3 over 2, will it be okay over here? Because 1.5 plus 1 is still a positive number, and still okay on the second logarithm here, so 1.5 minus 1 is still greater than 0. So that's it for today's lesson, and as always, if you have any questions, please make sure you ask in class. Take care, guys!